So again, like I just got done saying, all 19 formulas that we went over for this section will be on this test, including some formulas that we didn't just talk about, where you have your special right triangle, or maybe even a sine, cosine, tangent problem. Again, there's a little bit of trig on the test, not much, but there's a very little bit. All right, so you could use things like special right triangles, the Pythagorean theorem, Pythagorean triples, our SOHCAHTOA. All those things are fair game. Now, you don't necessarily have to use all of them. And again, there's different ways to do different problems. So if you choose to do it one way, you might be using SOHCAHTOA. Or you might be able to use a special right triangle. So again, not everything is on there, but a few problems do use trig. All right? Now, number one. So, I'm going to go through the entire review. Again, you should always include your units. Anytime you're talking about area, they should be in units squared. Anytime you're talking about just a single dimensional measurement or perimeter, it should be in just regular units. When we get after spring break, when we get into volume, volume is units cubed. All right? So, again, keep that in mind as you write your units on each of these things. Number one, we have area. We have a triangle. So you have to know your formulas. Again, the formula for this one, area is equal to 1/2 base height. Now, which one's base, which one's height?
The bottom one.
The bottom one has nothing to do with it, because we have a right angle. Again, so these two are going to be the ones that we use as base and height, because they are perpendicular. Again, base and height are always perpendicular to each other. Base doesn't always mean bottom. You can take a shape and rotate it. The base doesn't have to be on the bottom. Same thing with when we get to 3D shapes. We'll be talking a lot about base, and base does not mean bottom, because you can take a three-dimensional shape, tip it over. Is the base on the bottom? No, it's on its side now, and it's not on the bottom anymore. So, all right, so on here, shh. Again, they have to be perpendicular. So, these two are going to be used as base and height. Now, it doesn't matter which one you call which, so you could do it either way. But base we can say is 12, height we can say is 5. Half of 12 is 6. 6 times 5 is 30. So our answer here is 30, and then remembering units, centimeters squared. So again, you have to identify what formula you're using, identify the parts to plug in, plug them in, and then simplify. That's it. On some problems, you're going to have to solve instead of simplify. All right, and we'll have a few on here. You will have composite figures. So we have a couple composite figures here on number 2 and 3. On this one, you can split this a couple different ways. I'm going to split it by drawing a line this way. Could we have also split it here? Yeah. Again, they should both give us the same answer. Either way, we have rectangles. So this rectangle down here, I got to find the other dimension, because our formula for area of a rectangle is base times height. So this side is 14, that side's 9. 14 minus 9 is 5. So we're going to do base times height, which is 15. All right. Then we have, on this part, base times height, 12 times 9, which is 108. Guys, try not to shout out the wrong answer. I don't know if you're doing it on purpose or if you're giving me problems here, but use a calculator if you need it. Now, that being said, a lot of stuff like these simple questions where you're not using big numbers, when it comes time for FSA, they're probably going to be on the non-calculator section. All right? A lot of basic problems from this could be on non-calculator. Again, remember, you have two sections when it comes to FSA, calculator and non-calculator. If they're real numbers, you're not going to need a calculator. All right, so we have 108, we have 15. So 108 plus 15 is 123. And again, this would be in inches squared. You should always include your units. All right, units. The shaded area. You can do this problem several different ways. We do have a big rectangle. and then we have a triangle on the inside. You can look at this as a composite figure. We have a rectangle minus the triangle. However, our formula for a rectangle is what? Our formula for area of a triangle is? So what's going to happen if we find the area of this triangle? It should also be the same as the shaded area, because that should be the other half, right? Because if this is base times height for the entire rectangle, and this is half of that, then the shaded area is the other half. So you could just use the one formula. Otherwise, again, you could find the area of the rectangle first and then subtract, but you're going to get the same answer. So, 1/2 base times height. Half of 6 is 3. 3 times 10 is 30. And that's going to be our answer. Now, if you didn't get that, that's fine. You could have found the area of the rectangle first, which would have been 60. And then the triangle is 30. And 60 minus 30 again is 30. Either way, you get the same answer. So, 30 centimeters squared. Number 4, we have a octagon, right? It looks like a stop sign. There's 8 sides here. Our formula for area of an octagon, area equals either 1/2 ASN, or you could use area equals 1/2 AP. Doesn't matter which one you do, right? Because S times N is your perimeter.
Which one's easier, do you think?
Again, it depends what they give you. Because if they just give you the 3 pieces, I just plug into this formula. If they give you the perimeter, then I'd use the other one. If they gave you a question where you had to find the perimeter and the area, I'd find perimeter first, and then I'd use the second formula. Question? ASN, apothem, length of a side, number of sides. So we have, this is our apothem. We have the length of a side, and then the number of sides is what? Apothem. Again, just shh. So many teachers pronounce it apothem. It's supposed to be apothem, but if you want to spell it correctly, go with apothem. All right. You know, it's not just her. I bet if you asked half the teachers here, they would say apothem. All right. But anyway, area equals 1/2. 12.1 times 10 times 8. So, multiply this together. Now, you can multiply in whatever order you want to. So, if you want to switch this around, I'd probably multiply the middle 2 and the outside 2 first to make it easier. Because this one will get rid of my decimal and have 101. Half of 8 is 4. And then I can do 121, I meant. 121 times 4 is 484. Again, don't need a calculator. Don't. So again, I multiplied these 2 first, that gives me 121. I multiplied the 1/2 and the 8, that gave me 4. 121 times 4 is 484. Alright, on this one, let me write it in the blank, 484 centimeters squared. Alright, for the next one. This one's using a little bit of algebra. It's not just plugging in and simplifying. You have to solve, right? So again, there is quite a bit of algebra in this section. We have all the different pieces. We don't need all these pieces. Does this tell me anything for the shape? No, you don't need that. Does this tell me anything? No, it's useless. If I had something with perimeter, then I need those. But I don't need those for anything if I'm dealing with just area. So we have our area given to us. We're looking for the height. The formula is area equals, and there's several different ways that you can say this. So I don't know how Ms. Oswald gave it to you guys. I always say it as 1/2 base 1 plus base 2 times the height. All right, good. So the reason why I do it this way is because really you're taking an average of your 2 bases and then multiplying by the height. So, but you can multiply in whatever order you want. So we have 1/2. The 2 bases are given to us, 12 and 22. We're looking for the height. The area was given to us. That's 204. So we have 12 and 22. 12 and 22 is going to add up to 34. Half of 34 is
17.
17. So we have 17h. Divide off 17, and you get 12. All right. So the height here is 12, and it's only meters, not meters squared this time because it's a single dimensional measurement, right? So now, on number 6, you have a kite. This is area equals 1/2 d1 times d2. You could also look at it as two triangles. So if you want to use your triangle formula, it's really the same, right? You just have to double one of those triangles. But again, that's our formula, 1/2 d1 d2. The overall diagonal here is actually 16 for this one. Oops, sorry, I wrote the wrong thing. I was thinking about 16 already. So 1/2 times 16 times 20, which 1/2 16 is 8. 8 times 20 is 160. And that's in centimeters squared. That's it. I did 1/2. 1/2 of 16 was 8. 8 times 20 is 160. Or you could have done it even easier. 1/2 of 20 is 10. 10 times 16 is 160. Again, you're only multiplying by a half once. Yeah, again, most common mistake on, yes, be careful. Most common mistake on the formulas that include the 1/2, do not distribute the 1/2. You're doing all multiplication on a lot of these problems. You don't distribute if it's all multiplication. You're only multiplying by 1/2 once. If you start distributing 1/2, that means that you're actually doing a fourth if you distribute to two different values. So, again, you only multiply by the 1/2 once, whether it's after you multiply them or before you multiply them, it doesn't matter.
Can you multiply 16 and divide by 2?
Multiply these two and then divide by 2? That's fine. Yeah. Again, that'd be another way of doing that. All right. So now, on 7, we have perimeter. All right. So we're given area. We're given two measurements. We need perimeter. If this is 15, the other side is congruent, so that's also 15. We have this part's 9. I had several people in my one class tell me, couldn't I just use S times N? No. That's the perimeter formula where it's perimeter equals S times N is only for a regular polygon. So on here, we're using the equation for a parallelogram. So the area is given to us. We're using area equals B times H. Right? Area is 162. The base is what we don't have. So we don't know what the base is. The height is given to us. This is our height. So now divide off 9 and you get 18. So the base is 18. That means both of these sides can act as our base, which is 18. So now we have 15 and 15, which is 30. 18 and 18, which is 36. Add them all together, and that's 66. And now, this is perimeter, so it's a single dimensional measurement, so it's in inches, not inches squared. For our shaded area, so now, you can do this one several different ways. All right? Again, you can do this as our equation for our regular polygon, and then you could divide by however many pieces there are and do a lot of other stuff. There's an easier way to do this problem, though. If you just split this up, we have a bunch of triangles. And this is a hexagon, right? These are all what type of triangles? Okay, they are isosceles, but even more so they are equilateral. So, now, the easiest way to do this problem is going to be, they give us the apothem, which is this length right here, right? They give it to us.
Where do they give it to us? Oh,
off to the side. They give us the length of the side. For one of these triangles, the apothem is like my height, and the side is like a base, right? So if I just use my formula for area of a triangle, which is actually what my other formula is based off of, 1/2 my height, which was 6.93, times my base, which was 8, so So again, really, I'm just using my formula for area of a triangle. I'm calling this my height, this my base, and I'm doing area of a triangle instead. So now, this is going to be one triangle. How many triangles are shaded? 1, 2, 3, 4 equal our triangles. So I can multiply this whole thing at the end by 4. So now I just multiply it out. Now, somebody give me that. I don't have that one in my head. I don't have a calculator up here. 110 point what? 88? Alright. That's the first one that really required a calculator, probably. You can do the 1/2 ASN. Now, guys, listen. So let me show it off this side. Let me use a different color. If you wanted to use ASN on this one instead of what I just did. So over here, I use the formula for a triangle. Right? And then I multiplied it by 4. Right? There's 4 triangles there. If you used 1/2 ASN instead, it gives you the same thing. 1/2 ASN. A is 6.93. S is 8. And N is, well, N is the number of sides, which here is 6 for the entire figure. But if you just want to find the shaded, you could just do times 4. Now, if you did times the 6, you'd have to take your formula at the end and multiply whatever you get from this by, well, you have 4 out of 6. So you can multiply it by 4/6. Again, it's easier if you just plug in 4, which is why I said think of it as a triangle. It's the same formula. Again, our formula for a regular polygon is based off of our formula for area of a triangle anyway. If you go back to when we did it the first time in the Springboard book, and I showed you splitting it up, we used the formula for a triangle, and we replaced base with side and the H with A. Right? That's what we did the first time when I showed the Springboard pages. I drew my lines. Alright? So, it's okay to use formula for area of a triangle and then go from there. On 9, we have the height is what we're looking for. This is an obtuse triangle. The height's on the outside of the triangle. Right? Now, they gave us the base. This is the base way over here. I don't need to know anything else. I have base, I have area, I just need height. So, area equals 1/2 base times height. Area is 70. Base is 14. Looking for height. So, 1/2 of 14 is 7. 70 divided by 7 is 10. And that's my height. And this is in inches, not inches squared. The last one, I forgot to write it up here. The last one was in inches squared, because it was area. Again, if it's area, it's inches squared. If it's looking for a single dimensional measurement, any single dimension, height, base, apothem, length of side, those are all single dimensional measurements. Same thing with perimeter. Perimeter is single dimensional because it's a distance. Even though it's a distance around a figure, it's a distance, which is single dimensional. So, area is the only thing that gets squared. Alright? And then when we get to volume later on, volume gets cubed. Alright. Number 18. 18 is a trapezoid. Alright? Sorry, not 18. Sorry, 10. I saw the 8. I combined them. It's been a long day. Number 10. It's a trapezoid. Area of a trapezoid is 1/2 base 1 plus base 2 times the height. We have the height over here off to the side. We know it's the height because it's perpendicular to the two bases. This can be base 1. This can be base 2. Do we need 10 for anything? No. Don't need that. Now, if you forgot the area formula for a trapezoid, could you use that so you do area of a rectangle and area of a triangle together? Yeah. But then you'd have to use Pythagorean theorem and a bunch of other stuff. And actually, no. You can get away without doing Pythagorean theorem on this one. Sorry, if the other one was slanted, you'd have to use Pythagorean theorem. This one you actually have all the measurements you need to do that as well. So, area equals 1/2. Base 1 was 8, base 2 was 14, and the height was 8. So, 8 plus 14 is 22. Half of that is 11. 11 times 8 is? Again, really, if you have a calculator, it's nice. You can just plug all that in, and you're done. Now, if you are using a calculator, the one thing to be very careful of is making sure, if you have a calculator where you type the whole thing in, use parentheses. Because if I type this equation in without parentheses, would it give me the right answer?
No, sir.
No. All right. If you're using a calculator that doesn't allow you to type the whole equation in, make sure you do it in the correct order of operations, or it's not going to give you the correct answer. Again, otherwise, you might want to show your steps, show your work. Again, you might get points on the test if you show steps and show your work as you go, and that way you don't get as many points off if you just get the final answer wrong. All right, on number 11, we have a rectangle. They gave us perimeter. Well, I know if that's 7, this is also 7. I don't know what this side is. I'm going to call it X for now. Or, better yet, that's going to be my base. We could just call it B. So, whatever you want to call it. X, B, whatever. We're using our formula for perimeter. What is our formula for perimeter? We have one. Perimeter is just adding up all the sides. So, perimeter equals 7 plus base times base. We're like, it's going back to like middle school math now, right? So, on here, this is 14. This is now 2b. So now we're back to algebra. The perimeter is 34. Subtract off the 14, you get 20. Divide by 2, that's 10. That's our base. That's not our answer. We got to find the area. So area equals base times height. So 10 times 7 is 70.
Shut up. Okay, you cheated.
All right, we good? So that's the whole front. And we did that in 22 minutes, so we should be able to do the back in less, probably. All right. On the back. So we have, if the diameter of a circle is 8 inches, what is the area? So if you want to draw this, you can. You don't have to. If the diameter is 8, then the radius is what? 4. The reason why we found the radius is because, guys, the reason why I found radius is because we need to do the area, which calls for the radius. It's pi r squared. So pi times 4 squared. Now, 4 squared is 16. So we could leave our answer as 16 pi if we want to leave it in terms of pi. That's an exact value. And that would be in inches squared. That's one way to leave your answer. If you wanted to actually change it to a decimal, now, I should tell you what you would use as pi. Again, 3.14. So, I would use 3.14. Most of the time, that's what I would tell you to do on a test. I'm not normally going to tell you to use the pi button on your calculator. Again, use whatever is told to you in directions. So if they ask you for an exact value, leave it as an exact value. Leave it in terms of pi. If they don't, I would probably tell you to leave it as 3.14 if I told you to round, which would then give us what? 50 point what? 50.24?
Okay, your calculator's broke.
Hold on. Did you do pi or did you do 3.14? See, there's a difference. Again, this is why you have to read directions. Because if I told you to use 3.14 and then you use the pi button on the calculator, what did you get instead? 50, almost 50.3. Right? So again, it's going to vary from if you used just the rounded value of 3.14 or use the pi button on your calculator. The pi button on your calculator is more exact. However, if it's written in the instructions to use 3.14, your answer would be wrong if you write the wrong thing. Right? So make sure you follow directions. On number 13, If the area of a circle is 144 pi, what is the radius? So, same formula as before. Area equals pi r squared. They gave us the area. We're solving for the radius. Well, pi is on both sides. It's going to divide off and cancel out. So now all we have is 144 equals r squared.
Wait, why the pi going on the side? Why the pi going on the side?
Wait, this was 144 pi. That was the area. Pi r squared is our equation. So, on here, the pi's cancel out because if you divide both sides by pi, they go away. Yep, just square root 144. Again, do you need a calculator for that? No. So, that's just 12. So, our final answer is 12 centimeters. Number 14. The area of a circle is that. What is the diameter? Now, this is not in terms of pi, so I'd probably have to tell you to use 3.14, right? So on a question like this, we're going to use 3.14. We have the area equals pi r squared. We're plugging in for the area. We're going to be able to solve for the radius. First, divide off pi. In order to divide off pi here, we're going to have to do it as 3.14, which will give us what? 1,000. Now, we're going to have to take our square root again. What's the square root of 1,000?
It's 10.
10. Wait, what? It's not 10. It's not 10. You guys got me there. Square root of 100 is 10. You need a calculator for this one. 31.6 continuous. Alright. Is that our answer?
That's what I asked. Oh no. That's the radius.
It wants the diameter. We got to double that. So, if we times that by 2, that'd be 63.2, right?
Yeah. And that's your answer.
And that would be our answer.
3.16.
I lost.
Wait, what?
31.4.
Wait, what?
31.6. Times that by 2, because we're looking for the diameter. We had to multiply that by 2. That gave us the 63.2. Yeah. Yeah. Again, if I asked you to round it, it'd be 63.2, right? Or 63.22, whatever I asked you to round for. I didn't give directions on here. On a test, I'd tell you directions. All right, on 15. If the radius of a circle is 6 inches and the sector has an intercepted arc of 90 degrees, what's the area of the sector? So our formula for area of a sector, area equals m over 360 times pi r squared. Again, it's the fraction of the circle you're using times the formula for area of a circle. So we have 90 out of 360. For a circle, we had 6 as our radius. Now, 90 over 360 reduces nicely to just 1/4. Right? 6 squared is 36. What's 1/4 of 36? 9. That could be our answer. 9 pi is a good answer for our area. Now, that's in terms of pi. If you want to actually multiply out by 3.14, you could do that as well. What is it if you times 3.14? What was it?
I got 28.26.
28.26.
I got 34.9.
All right. So now, number 16, shaded area. Now, there's actually a name for this shape. This is what you call an annulus. We haven't covered it. Springboard doesn't go over it.
Is it going to be
Essentially, all we're doing is subtracting the little circle from the big circle. It's a composite figure, right? We just have a name for this composite figure. So yeah. So again, the big circle minus the little circle. If we actually care to know the formula for an annulus, guess what it is? it's the big circle minus the little circle.
It's a circle.
It is a composite figure.
It's a
So,
circle.
we have
It's a circle.
pi 10 squared minus pi 4 squared. 10 squared is 100. 4 squared is 16. Our answer here, subtract them, 84 pi. That'd be in terms of pi, and it's centimeters squared. Or, if we wanted to multiply out 3.14, you could do that as well. What does that give us?
263.76.
263.76. So again, those could be our two answers there, either in terms of pi or approximated.
Listen up here.
All right. Yes.
We never did. We did. We did.
260.8. Again, it depends on what I asked. I didn't give you any rounding directions here. That'd be fine for this. On a test, I'd tell you rounding directions.
Wait, hold on. Don't.
They are two concentric circles. What I was saying is there's a name for this actual shape where you have a circle missing in the center. It's called an annulus. Again, that's just extra. You don't have to know
On
that.
the test, you could leave, we don't have to round if we want to, you just leave it as a slide thing.
Again, depends on the directions, but I would accept terms of pi for most answers. All right. So, on number 17. The shaded area. This is a sector, right? So we have our formula for area of a sector again. Measure over 360 times pi r squared. Plug in the parts. We have 120 over 360 times pi 12 squared. 120 over 360 reduces nicely to 1/3. 12 squared is 144. 1/3 of 144 is 48. Yep. Now, this is in, again, since it's area, unit squared, inches squared. So 48 pi inches squared. Again, if you want to change it to a decimal, you could round that off. What's 48 times 3.14?
150.72.
What was it?
150.77.
Again, that's it. Now, on 18, the perimeter of a regular hexagon is 42 inches. The area of the hexagon is 127.26 inches squared. Find the length of the apothem. So, they gave us all the information we needed if we were to do this in terms of our formula 1/2 AP. Our area is given to us. Our perimeter is given to us. 1/2 of 42 is 21. Divide by 21. What is 127.26 divided by 21? I don't know either. Somebody with a calculator. I don't have a calculator if you're with me.
Bro, who stole mine?
Yeah, divide that by 21. 6.06. So that would be my apothem. Since the original value was given to 2 decimals, we're going to go ahead and round that off to 2 decimals. Did it go further than that? No? Okay. All right, now, number 19. What is the sum of the interior angles of a pentagon? So, this is n minus 2 times 180. Again, n minus 2 tells you the number of triangles, times 180 gives us the total sum. So, 5 minus 2 times 180. That's 3 times 180. A pentagon is 5 sides. Right? So, 3 times 180 is 540. Thank you. All right. On number 20, the sum of the exterior angles of a, who cares what I said? I just said the sum of the exterior angles. That means it's 360.
Exterior bank.
You can cross that off. It doesn't matter what that is. Whatever I put there is going to be 360. Don't miss that question.
360, babe. Wait, can you say everything?
Again, the sum of the exterior angles, no matter what shape it is always 360. All convex polygons have the sum of the exterior angles of 360.
Got it. Got it.
All right?
In the bag.
So I could have said dodecagon. I could have said decagon. I could have said hexagon. I could have said heptagon. I could have said 25,000 gon, and it's still 360.
Are we gonna have to know for the test what each of those shapes, how many sides they have by heart?
Are the words used? Yes. So should you know what they are? Yes. I'm not going to tell you what shapes I'm giving you. You guys should know up through 12. Yeah. So 11 instead of dodecagon, it's undecagon or undecagon. It's un decagon. Yeah. Yeah. All right. Anyway, 21. How many sides does a convex regular polygon have if the measures of one exterior angle is 45 degrees? Well, if we're talking an exterior angle, the formula here for one exterior angle is 360 divided by n. So if that's equal to 45, what's going to end up happening here is you're going to end up dividing 360 by 45. Right? Because first you'd multiply n over, divide by 45, and n is, here, I'll show my steps. So then, which is what? 8. Now, I could even ask, what type of shape is that? So, there's 8 sides. That's all I asked here. What is 8 sides? Octagon. You should know that. All right, number 22. How many sides does a convex regular polygon have if the measure of one interior angle is 108? There are 2 different ways that you can do this problem. All right, first method. So I'm going to do this both ways. You can decide which one's easier. N minus 2 times 180 over n equals 108. So we would have to multiply n to the other side. We'd have... So I'm going to do this. All right, multiply n to the other side, you get 108. At the same time, I'm going to go ahead and distribute the 180 here at the top. So 180 n minus 360. The n that was on the bottom, I got out of the bottom by multiplying it over to the other side. Oh, it's right there. I forgot to write it. Oh. All right. Yeah. So now we could subtract 180n, and we'd have negative 360 equals negative 72n. It's positive over here, so you'd have to minus it to get rid of a positive number, right? The negative is on the 360. So now, divide by negative 72. If you divide by negative 72, you get a positive what? Sorry. 360 divided by 72, guys. 360 divided by 72. 360 equals negative 72n.
Negative 360.
5.
Negative 72.
What is happening?
Alright. So, on here, we have, just let me focus it a little bit. N minus 2 times 180 over n equals 108. I multiplied n to the other side, so we have 108n over here. At the same time, I went ahead and distributed the 180. So, I did this. I times by n, if I show my work, it canceled off. I took the 180, I distributed to both of those. I did that all in one step. Then after we got that, we had the 180n. We had to subtract that off. So minus 180n, whoops, from both sides. We're subtracting it off. Subtract off 180n. And we have this. Negative 360 equals negative 72n. Then we had to divide by negative 72. Don't really have room for that, but negative 72. And we got 5n. That is not the easiest method.
No, it's not.
There's an easier way to do this.
Are you serious?
Where's the lid?
Again, I told you I was going to do two methods, right? Shh. I say the easier method for first. All right. The one that I think is easier is, yes, they gave us an interior angle. Does that mean we have to use the interior angle? No. Because we know the interior angle, we should know the exterior angle. What's the exterior angle going to be?
Oh, that's gonna be 7.
Oh,
Yeah,
yeah.
72. Right? We did 180 minus 108. That gives us the exterior angle of 72. Because now, we have a formula for that which is much easier, right?
Shoot up your entire house.
We just used it in the previous problem. 360 divided by n equals 72. And now it's just like the previous problem. We multiply n over to the other side and divide by 72, which gives us 5. Again, well, what happens normally on the test, yes, there's two different ways to do it, but most people see the words, we have an interior angle, so then they do this formula.
What's next to
Again,
7?
just because they give you an interior angle doesn't mean you have to use the interior angle.
What's next to 7? 360 equals 7.
Here, 360 equals 72n.
Oh, 72.
Alright, that's it. Alright, on 23, draw an example of a concave polygon and a convex polygon. Alright, here we go. Convex, anything that we've done before. So, there's a convex pentagon. There's a concave polygon. They're both pentagons. They both have 5 sides. But that's convex, that's concave. Again, as long as one angle is pointing inwards, it's concave. Yeah. Convert the following to degrees. So, we're going to multiply this by, again, if we're changing 2 degrees, the degree measure goes on top. So, 180 over pi. So when we multiply here, we now have pi in both top and bottom, so those can cancel out. This is going to give us 2 times 180 is 360. 360 over 5. So divide that, gives you what? That's our answer. On the next one, we're converting this one to radians. So again, if we're going 2 radians, then pi goes on top. So times pi over 180. So now, this is going to be 160 pi over 180. Again, you can reduce this. First, I'd go and reduce by 10. Get rid of the 0 if you divide by 10. So now we just have 16 over 18. What can we reduce both of those numbers by? 2. Just 2. Divide 16 by 2, you get 8. So we still have 8 pi on top. Divide 18 by 2, you get 9. That's our final answer. Yes. That is simplified. How else would you simplify it? But how would you divide? You can't divide 8 by 9. That is simplified.
Hey, that's mine.
Yeah. All right, 26. Circle C. Circle C has a center located at 3, 2, and a radius of 10. Circle D is located at 2, 5, and has a radius of 4. What is the sequence of transformations that proves that circle C is similar to circle D? Again,
I did not like that.
that was in Springboard, right?
No. This was in Springboard?
It was in Springboard. Yeah. It was the last section on similar circles. So, again, how can you prove something is similar? You have to map it onto the other one, right? So, take one, map it onto the other. So, on here, we're trying to prove that C is similar to D, so we'd want to map C onto D. So, first thing you can do is to move C to D, move that center point to this. So we could go, again, there's several ways of writing this. You could say X, we want to go -1, right? X -1, and Y +3. Or you could say left 1, up 3, right? Because again, we're moving C onto D. Then dilate by a scale factor of, well, C had a radius of 10, and the other one had a radius of 4. So I need to multiply 10 by something that would get it down to 4. How could I multiply 10 by something that would get it down to 4?
Oh, 1.4. 1.4? No, what's 0.4? It's 0.4. So I don't know what that fraction is.
It is 0.4. So if you wanted to say 0.4, sure. I would look at it as saying 4 over 10, which could be reduced to 2/5, which is 0.4. Huh? Yeah, so for B, again, the original radius for C is 10. We need to get down to 4, right? So it's going to be a value that's less than 1 because it has to get smaller. Now, what value are you going to multiply 10 by to get to become 4? Well, the way that you could always do that is figure out what. How can I phrase this? So if we have 10, right, and I want it to be 4, I'm going to multiply it by 4 and cancel out the 10 by putting it on the bottom. Because that's guaranteed to give me 4, right? Because if I put 4 on top and 10 on bottom, the 10s cancel out, right? So this fraction is what I'm actually multiplying by. Yeah. Yeah. Whatever you want it to become, put that value on top, put the original on bottom. That's going to be your fraction you're multiplying by. That's an easy way to do it. All right. That's the entire review. No longer than I had hoped to do, but